The Big Bang did not bang. There was no sound, no explosion, no violent eruption of matter into a pre-existing void. The universe did not burst forth like a firework into darkness. What we call the Big Bang was, in fact, silent, a noiseless stretching of space and time from a singularity of infinite density. The greatest event in cosmic history occurred in perfect silence, and everything you've been told about it may be fundamentally wrong. You've been misled by the language of cosmology itself. The words we use to describe the birth of the universe have betrayed us, painting a false picture in our collective imagination. Close your eyes. What do you see when you think of the beginning? A blinding flash? An explosion of light? A thunderous boom echoing through nothingness? That image, so visceral, so dramatic, so human in its conception, is perhaps the greatest misunderstanding in the history of human thought. What if I told you that the edge of our understanding isn't just out there, at the farthest reaches of space, but right here, at the very foundation of how we conceptualize cosmic birth? The Big Bang wasn't big, and it didn't bang. It was everywhere at once, and it was silent. Think about that for a moment. The greatest creation event in existence had no audience, made no sound, and happened everywhere simultaneously. There was no outside for it to expand into. Space itself was being created in that moment. Time was being born. The very concepts of before and after came into existence then. What does that do to your perception of reality? How does it feel to realize that the cosmic narrative you've internalized is built on a linguistic error, a metaphorical crutch that fails to capture the true nature of creation? Now imagine yourself at the edge of time, not as a witness standing apart from creation, but as a participant within it. Your very atoms compressed to a point of infinite density, your future existence encoded in quantum fluctuations. If you could rewind time, truly rewind it to its absolute beginning, what would you see? A moment of creation, or something else entirely? The answer might shatter everything you think you know about existence. When we peer back toward the cosmic dawn, using our most sophisticated telescopes, we're looking at light that has traveled for nearly 13.8 billion years to reach us. We call this the observable universe, the spherical region from which light has had time to reach Earth. Since the universe became transparent about 380,000 years after the initial expansion began. But what lies beyond that boundary? What exists past the cosmic horizon of our perception? Here is the first mind-bending truth. We don't know. We cannot know. The universe beyond our observable bubble might be infinite, or it might eventually curve back on itself. It might be homogeneous, identical to what we can see. Or it might be wildly, unimaginably different. The edge of our knowledge isn't a place. It's a fundamental limitation of perspective, a horizon that moves with us, always the same distance away, no matter how advanced our instruments become. Imagine standing on the shore of an infinite ocean at night. Your flashlight illuminates only a small circle of water before you. Does the character of the ocean change beyond where your light can reach? Are there different currents, different creatures, different laws of nature itself? You have no way of knowing. The universe presents us with the same maddening limitation. We can only see as far as light has had time to travel since the beginning. a mere 93 billion light-years in diameter, which may be an infinitesimal fraction of what actually exists. The cosmic horizon isn't just a spatial boundary, it's a temporal one. When you look at the most distant galaxies, you're seeing them not as they are now, but as they were billions of years ago. The present state of those galaxies is as inaccessible to us as the future. They exist in our past, while simultaneously existing in their own present, which we will never witness. The universe enforces a kind of cosmic censorship on our perception, allowing us to see only echoes and afterimages, never the full picture in real time. If the universe as we understand it, this vast, expanding realm of galaxies and dark energy, is merely a local phenomenon? What if we're living in just one bubble, in a vast, frothing sea of universes, each with its own laws of physics, its own dimensional structures, its own concept of time? The multiverse theory suggests exactly this, that our universe, infinite though it may appear, might be just one of countless others, separated from us by dimensions we cannot perceive, or boundaries we cannot cross. Take a breath. Feel the weight of your body. Touch the surface nearest to you. These sensations feel real, solid, undeniable. But what if this reality, everything you've ever known or experienced, is just one configuration of possibilities in an endlessly branching tree of quantum outcomes? What if, in another branch of that tree, you made a different choice this morning, took a different path, became a different version of yourself? What if every decision point in the history of the universe has created infinite parallel realities, each as real as the one you're experiencing right now? Quantum mechanics, that bizarre realm of physics that governs the very small, suggests this might be true. Particles exist not in definite states, but as clouds of probability, until observed. Reality itself seems to be probabilistic at its core, determined not by certainty, but by statistical likelihood. When we scale this principle up to the cosmic level, we're faced with the vertigo-inducing possibility that our entire universe might be just one manifestation of countless possible universes, all existing simultaneously. The edge of everything we know might not be a place at all, but a boundary between different modes of existence, between the actualized reality we experience and the sea of potentiality from which it emerged. Consider the horizon of a black hole, that boundary beyond which nothing, not even light, can escape. We call it the event horizon, because events that occur beyond it can never be observed from our side. Information that crosses that boundary is, for all practical purposes, lost to our universe. But what happens to that information? Does it truly cease to exist? Or does it continue in some form we cannot access or comprehend? The black hole information. Paradox has troubled physicists for decades. It suggests a fundamental incompatibility between quantum mechanics, which states that information cannot be destroyed, and general relativity, which implies that information falling into a black hole is irretrievably lost. This isn't just an academic puzzle. It strikes at the very heart of our understanding of reality. If information can truly be destroyed, then the universe is not deterministic. The future cannot be predicted from the past. Even in principle, causality itself breaks down. What if black holes are not cosmic dead ends? but gateways, portals to regions of space-time, or modes of existence that lie beyond our current understanding? What if the information that falls into them isn't destroyed, but transformed, encoded in ways we haven't yet conceived? The edge of our knowledge here isn't just a limit of our instruments or our theories, it's a potential gateway to an entirely new understanding of cosmic structure. Let's pull back further, to the very fabric of space-time itself. Einstein showed us that space and time are not separate entities, but aspects of a single continuum, space-time, that can be warped and curved by mass and energy. This revelation transformed our understanding of gravity, recasting it not as a force acting across space, but as a curvature of space-time itself. Massive objects like stars and planets create depressions in the fabric of space-time, and smaller objects move along these curved pathways. But what is space-time made of? What is the fundamental substance that warps and bends in the presence of mass? Despite a century of progress since Einstein's revolutionary insights, we still don't know. We can describe how space-time behaves, but we cannot explain what it fundamentally is. At the smallest scales, the Planck length, about 10⁻⁵ meters, our models break down entirely. Quantum effects should dominate at this scale, but we have no complete theory of quantum gravity to describe what happens. This isn't just a gap in our knowledge, it's an abyss. The edge we're approaching here is the boundary between the world we can model mathematically and a realm that defies our current frameworks of understanding. It's as if we've built an exquisite map of reality, only to discover that, beyond a certain scale, the territory becomes unmappable using our existing tools. What lies beyond that edge? Perhaps a quantum foam of space-time, where dimensions themselves fluctuate and transform. Perhaps geometric structures we cannot currently imagine. Perhaps something so alien to our cognitive frameworks that we lack even the language to conceptualize. The horizon of our understanding here isn't just a limit of knowledge, it's a limit of imagination itself. Now let's zoom out even further, to the largest scales of the observable universe. When we map the distribution of galaxies across billions of light-years, we discover a cosmic web, a vast network of filaments and clusters of galaxies, with enormous voids in between. This structure, spanning scales that defy comprehension, appears to have been encoded in the earliest moments of the universe's expansion. But what shaped this pattern? What forces determined this particular configuration of matter rather than another? We call it cosmic inflation, a brief but explosive expansion of space-time in the first fraction of a second after the Big Bang. But what triggered inflation? What caused it to stop? What existed before it began? These questions take us right back to the edge of time itself, to the boundary between what we can infer from observation and what remains purely speculative. The universe appears to be expanding at an accelerating rate, driven by a mysterious force we call dark energy. But what is dark energy? We don't know. We can measure its effects on cosmic expansion, but we cannot explain its nature or its origin. Similarly, the galaxies we observe appear to be held together and structured by a substance we call dark matter. But what is dark matter? Again, we don't know. We can detect its gravitational influence, but we cannot directly observe it or explain what it's made of. Together, dark energy and dark matter make up about 95% of the content of the universe. Think about that for a moment. Nearly everything that exists, 95% of reality, is currently beyond our ability to explain or directly detect. We're like sailors navigating by the 5% of icebergs visible above the water, trying to map an ocean whose depths remain largely invisible to us. This isn't just a gap in our knowledge, it's a humbling reminder of how provisional our understanding truly is. The edge here isn't a boundary between the known and the unknown, but between the known and the potentially unknowable. We may be approaching fundamental limits of what can be observed, what can be inferred, what can be understood within the framework of our current scientific paradigms. What if the universe isn't just stranger than we imagine, but stranger than we can imagine? What if the tools of observation and reason that have served us so well, from the earliest stargazers to the most sophisticated modern physicists, are fundamentally inadequate to grasp the true nature of reality? What if consciousness itself, the miraculous emergent property that allows you to comprehend these words right now, is both our greatest instrument of discovery and our greatest limitation? Your conscious experience feels continuous, unified, deterministic. You experience yourself as a single entity moving through time in a linear progression. But what if this experience is itself an illusion, a necessary simplification created by your brain to navigate a reality far more complex and counterintuitive than raw perception could process? What if your sense of time's arrow, of cause preceding effect, of the clear boundary between past and future, is merely a cognitive construct rather than a fundamental feature of reality? Quantum mechanics suggests exactly this possibility. At the quantum level, time behaves differently. Particles can become entangled, sharing information instantaneously across vast distances in apparent violation of the cosmic speed limit, the speed of light. The clear distinction between past and future that shapes our everyday experience blurs in quantum systems, suggesting that time itself might not be the fundamental, forward-flowing river we perceive it to be. What if time is not a dimension we move through, but a dimension that moves through us? What if the present moment, this exact now that you're experiencing, is not a point sliding along a timeline, but a continually shifting boundary between quantum possibility and collapsed actuality? What if the future doesn't just not exist yet, but exists in a fundamentally different state of being, as a cloud of probability rather than determined fact? These aren't just philosophical musings. They're implications drawn from our most successful physical theories, theories that have been confirmed by experiment time and again. The edge we're approaching here isn't just a limit of knowledge, but a limit of intuition, a boundary beyond which reality itself seems to violate our most basic expectations about how the world should work. Consider the double-slit experiment, one of the most famous demonstrations of quantum weirdness. When individual particles like electrons are fired through two parallel slits onto a detector screen, they don't behave like tiny bullets, creating two bands of impacts. Instead, they create an interference pattern, a series of alternating bands of high and low impact density, as if each particle had gone through both slits simultaneously and interfered with itself like a wave. Even more bizarrely, if we place detectors at the slits to observe which path each electron takes, the interference pattern disappears. The very act of observation appears to change the behavior of the particles, collapsing wave-like behavior into particle-like behavior. Reality itself seems responsive to observation, to consciousness. The boundary between observer and observed, between mind and matter, blurs. What are we to make of this? What if consciousness itself is not just a late-emerging property of highly evolved brains, but a fundamental feature of reality? A force or field that interacts with matter in ways we're only beginning to understand. What if the edge of everything we know isn't just out there in the cosmos, but in here, in the mysterious interface between mind and world? These questions take us to the boundary between physics and metaphysics, between science and philosophy. They remind us that despite all our technological prowess, all our mathematical modeling, all our sophisticated theories, we remain limited, beings trying to comprehend a reality that may transcend our cognitive capacities in fundamental ways. Let's return to the beginning, to the silent, spaceless, timeless point from which our universe emerged. Physicists call it a singularity, a place where density becomes infinite, and the laws of physics as we understand them break down completely. But what is a singularity? Is it a physical reality, or is it a mathematical artifact, a sign that our equations have reached their limit of applicability? Is the Big Bang singularity an actual event in cosmic history, or is it the edge of what can be modeled, the boundary beyond which our conceptual frameworks fail? Some theories suggest that the Big Bang wasn't the beginning at all, that our universe might be part of a much larger cosmic cycle of expansion and contraction, a big bounce rather than a Big Bang. Others propose that our universe budded off from a parent universe through a process of quantum fluctuation. Still others suggest that time itself began at the Big Bang, making the question of before not just unknown, but meaningless, like asking what's north of the North Pole. The edge we're approaching here isn't just a limit of observation or theory. It's a limit of language itself. Our temporal concepts of before and after, our spatial notions of inside and outside, our causal framework of from and to, all break down at the cosmological boundary. We're trying to describe a reality that precedes the very conceptual, tools we use to make sense of experience. What does it mean to exist in a universe with such fundamental limits to knowledge? What does it mean to be conscious in a cosmos that seems, at its deepest levels, to defy the very logic that consciousness employs to make sense of experience? These aren't just scientific questions, they're existential ones. They go to the heart of what it means to be human, to be a thinking reed in an apparently unthinking universe, to be a transient configuration of matter capable of contemplating its own existence. Perhaps the edge of everything we know isn't a deficit, but a gift, an invitation to humility, to wonder, to the recognition that mystery is not the enemy of knowledge, but its complement. Perhaps the universe isn't a puzzle to be solved, but a reality to be experienced, a mystery to be embraced rather than conquered. Look up at the night sky. Those points of light you see have traveled across unimaginable distances, through the vacuum of space, through the atmosphere, through your eye, to create patterns of electrochemical activity in your brain that you experience as stars. In that moment of perception, the boundary between you and the cosmos dissolves. You are not separate from what you observe. You are a temporary configuration of the same matter and energy that makes up those stars, obeying the same physical laws, emerging from the same cosmic origin. What if the edge of everything we know isn't a place at all, but a perspective? The perspective of finite beings trying to comprehend infinity, of temporal beings trying to grasp eternity, of limited minds reaching for limitless understanding? What if the universe is not just vaster and more complex than we imagine, but vaster and more complex precisely in ways that transcend our capacity to imagine? This doesn't mean we should abandon the quest for knowledge or succumb to mysticism. The scientific enterprise, with its empirical methods, its mathematical rigor, its commitment to evidence and reason, remains our most powerful tool for pushing back the boundaries of ignorance. But perhaps we need to hold our theories more lightly, to recognize their provisional nature, to understand that the map is never the territory, and that reality always exceeds our conceptual frameworks. Consider the history of cosmology itself. A series of expanding horizons, each giving way to an even larger vista. For early humans, the edge of everything known might have been the horizon line, the boundary between earth and sky. For ancient astronomers, it might have been the outermost celestial sphere carrying the fixed stars. For 19th-century scientists, it might have been the edge of the Milky Way, thought to comprise the entire universe. Each generation has pushed the boundary further, revealing a cosmos vastly larger and more complex than previously imagined. What unknown horizons await future generations? What paradigm shifts will make our current understanding seem as limited as the geocentric cosmos of antiquity seems to us? The edge of everything we know isn't fixed. It's a moving boundary, receding, as knowledge advances, revealing new mysteries even as old ones are solved. This is the paradox of scientific progress. The more we learn, the more we become aware of what we don't know. Knowledge doesn't eliminate mystery. It reframes it, pushes it further out, transforms it. The cosmic horizon is not a destination, but a journey, an endless exploration of a reality whose depths may be truly unfathomable. And yet, amidst this vast uncertainty, we've discovered patterns, regularities, mathematical structures that seem to capture something essential about the nature of reality. The physical constants that govern cosmic evolution, the gravitational constant, the speed of light, the charge of an electron, appear finely tuned to allow for the emergence of complexity, of stars and planets, of life and mind. Why these particular values? Why a universe that permits beings capable of understanding it, even partially? Is this apparent fine-tuning merely a selection effect, the inevitable perspective of observers who could only exist in a universe compatible with their existence? Or does it point to something deeper, a cosmic principle or purpose beyond our current understanding? We stand at a precipice of knowledge, where scientific inquiry meets philosophical reflection. The questions we ask at this boundary are not just about what exists, but about what it means to exist. Not just about what we can know, but about what it means to know. They remind us that despite all our technological sophistication, all our mathematical prowess, we remain wondering beings in a wonder-filled cosmos, using finite minds to contemplate infinity. What if the edge of everything we know isn't a limitation, but an opportunity? A chance to combine scientific rigor with philosophical depth, empirical precision with imaginative reach? What if the greatest discoveries await not just in the furthest galaxies or the smallest particles, but in the creative synthesis of different modes of understanding, different ways of engaging with mystery? Consider the concept of emergence. The way complex systems and patterns arise from relatively simple interactions. Consciousness itself may be an emergent property, arising from the networked activity of billions of neurons, each operating according to relatively simple electrochemical principles. Yet the whole, the integrated experience of being you, right now, reading these words, seems to transcend the sum of its parts in ways we're only beginning to understand. What if the universe itself is such an emergent phenomenon? What if physical laws are not foundational but emergent, patterns that arise from deeper, currently inaccessible levels of reality? What if what we call physical reality is itself an information structure, a computational process, a set of mathematical relationships, rather than things in the conventional sense? These speculations take us to the furthest edge of scientific theory, where physics meets information theory, where material reality merges with mathematical structure. They suggest that the boundary between the physical and the abstract, between matter and information, may be less absolute than our everyday experience suggests. What does it mean that mathematics, a system of abstract relationships developed by human minds, so effectively describes the physical world? Physicist Eugene Wigner called this the unreasonable effectiveness of mathematics in the natural sciences. Is mathematics invented or discovered? Does it exist independently of minds that comprehend it? Is the deep mathematical structure of physical law a sign that reality itself has an inherently mathematical nature? These questions take us to the edge, not just of what we know, but of what knowledge itself means. They remind us that the scientific enterprise, for all its empirical grounding, rests on philosophical assumptions about the nature of reality, the reliability of sense perception, the universality of logical principles. Science doesn't operate in a philosophical vacuum, but depends on metaphysical commitments that themselves cannot be proven empirically. Perhaps the edge of everything we know is not just an external horizon, but an internal one. A boundary within our own ways of knowing, a limit inherent in our conceptual frameworks. Perhaps the greatest discoveries will come not just from better instruments or more powerful theories, but from radical shifts in how we conceptualize knowledge itself, from new cognitive frameworks that transcend the limitations of our current paradigms. This isn't just speculative philosophy. It's a recognition that throughout the history of science, the most revolutionary advances have often come not from incremental progress within existing frameworks, but from paradigm shifts, fundamental transformations in how we conceptualize the subject matter itself. The Copernican revolution wasn't just a better model of planetary motion, it was a radical reframing of humanity's place in the cosmos. Einstein's relativity wasn't just a refinement of Newtonian mechanics, it was a fundamental reconceptualization of space, time, and gravity. What paradigm shifts await us at the current edges of knowledge? What conceptual revolutions might transform our understanding of consciousness, of quantum reality, of cosmic origins? What if the questions we're asking are themselves limited by frames of reference that future generations will transcend in ways we cannot currently imagine? The edge of everything we know isn't just a boundary between knowledge and ignorance, it's a creative frontier, a place of transformation, a threshold beyond which new modes of understanding become possible. It's both humbling and exhilarating to stand at this edge, to recognize both the vastness of what remains unknown and the incredible journey that has brought human understanding to its current state. From the first humans who looked up at the Etoile night sky and recognized patterns in the stars, to the contemporary physicists probing the earliest moments of cosmic history, we've been edge dwellers, boundary crossers, horizon seekers. The quest to push back the edge of knowledge, to venture into the unknown, to transform mystery into understanding while honoring the mysteries that remain. This is one of the defining features of human consciousness, one of the noblest expressions of what it means to be a thinking being in a cosmos vast beyond comprehension. What if the edge of everything we know isn't a place of limitation, but a place of possibility? Not an ending, but a beginning. What if the boundary of human understanding isn't a wall, but a doorway? Not a dead end, but an invitation to new ways of knowing, new modes of being, new relationships with the mystery that surrounds us and constitutes us. As you contemplate the your cosmos tonight, whether through a telescope, through images from our most powerful instruments, or simply through the naked eye view of stars scattered across the darkness, remember that you stand at an edge. You are a conscious fragment of a universe in the process of awakening to itself, a temporary configuration of matter and energy capable of contemplating its own origins, a thinking reed in an unthinkably vast cosmos. The edge of everything we know isn't out there in the farthest galaxies or the earliest moments of time. It's here, now, in the miracle of consciousness, in the mysterious interface between mind and world, in the astonishing fact that a universe of apparently mindless matter has given rise to minds capable of understanding, however partially, the very laws that govern their existence. What greater mystery could there be than this? What more profound edge could we explore? The boundary between knowing and being, between the observer and the observed, between the cosmos and the consciousness that contemplates it, this is the ultimate edge, the final frontier, the horizon, that moves with us on our endless journey of discovery. And so we return to where we began, to the silent, spaceless, timeless point from which our universe emerged. The Big Bang did not bang. There was no sound, no explosion, no violent eruption into pre-existing void. There was only the silent birth of space and time themselves, the quiet emergence of the potential for everything that would follow. Galaxies and stars, planets and moons, oceans and mountains, living cells and conscious minds. In that silent beginning was encoded not just the physical constants that would govern cosmic evolution, not just the seeds of galaxies and stars, but the potential for beings who would one day look back toward that beginning and wonder, who would push against the edge of knowledge, who would grapple with the limits of understanding, who would stand in awe before the mystery of existence. You are the universe becoming conscious of itself. You are matter awakened to its own meaning. You are the edge of everything known, gazing out into the unknown. And in that gaze, in that wonder, in that relentless questioning, something profound is happening. The universe is not just expanding physically, but deepening in meaning, complexifying, in understanding, awakening to its own nature through the miracle of conscious experience. What lies beyond the edge of everything we know? Perhaps the answer isn't a what, but a who. You, the questioner, the wonder-struck consciousness, the thinking fragment of cosmos, standing at the boundary between the known and the unknown, bearing witness to the miracle of existence. You are not separate from the mystery you contemplate. You are an embodiment of it, a manifestation of the universe's capacity to evolve systems complex enough to reflect on their own origins, to push against the boundaries of understanding, to stand in awe before the wonder of being itself. This is the greatest discovery at the edge of knowledge. Not that the universe is vast beyond comprehension, not that reality transcends our conceptual frameworks, but that consciousness itself, the miracle happening within you right now, is the universe's way of exploring its own depths, of pushing back the edge of everything known to reveal new horizons of possibility, new domains of mystery, new frontiers of understanding. The edge beckons. The journey continues. The mystery deepens. And you, conscious, questioning, wonderstruck, you are both the explorer and the territory, both the knower and the known, both the edge and what lies beyond it. In your consciousness, the universe contemplates itself. In your questions, reality explores its own depths. In your wonder, existence awakens to its own meaning. What greater adventure could there be than this? What more profound journey could we undertake? The edge of everything we know isn't a boundary to fear, but a horizon to embrace. An endless invitation to deeper understanding, to greater wonder, to more profound communion with the mystery at the heart of being itself. We live in an expanding universe, a vast cosmic tapestry, stretching outward in all directions, carrying galaxies away from each other like dots on an inflating balloon. This is the bedrock truth of modern cosmology, established nearly a century ago when Edwin Hubble observed distant galaxies racing away from us, their light stretched into redness by their retreat. The farther a galaxy, the faster it appears to recede. A simple relationship that revealed a profound truth. The universe is not static, but dynamic, not fixed, but flowing. Yet this known truth conceals deeper mysteries. The expansion of the universe is not like an explosion, with matter flying outward from a central point into pre-existing space. There is no center from which the universe expands. There is no edge toward which it grows. Every point is expanding, away from every other point, with space itself stretching between them like an infinite cosmic fabric, being silently pulled in all directions simultaneously. Think about what this means. If you could somehow position yourself at what you perceive as the edge of the universe and fire an arrow outward, what would happen? Would it hit a cosmic wall? Would it cross some boundary between what is universe and what is not? No, it would simply continue through space that exists but which we cannot see from our vantage point, space that is as real as what falls within our cosmic horizon, but which remains forever beyond our observation. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. In the first fractions of a second after the initial expansion began, temperatures reached values that defy comprehension. Not millions or billions, but trillions of degrees. At these temperatures, matter as we understand it could not exist. There were no atoms, no atomic nuclei, not even stable protons or neutrons. There was only a seething plasma of quarks and gluons, fundamental particles swimming in an ocean of pure energy so intense that the distinction between matter and energy blurred into meaninglessness. Imagine standing at the shore of creation, watching as the universe cooled from this inconceivable heat. As temperatures fell, quarks condensed into protons and neutrons. Minutes later, yes, mere minutes after the beginning of expansion, these protons and neutrons fused into the first. Atomic nuclei in a process we call primordial nucleosynthesis. But the universe remained so hot, so dense with energy, that light itself could not travel freely. Photons bounced endlessly from particle to particle, trapped in a cosmic fog. For 380,000 years, the universe remained opaque, a luminous mist through which nothing could be seen. Then, as expansion continued and temperatures dropped further, something remarkable happened. Electrons, which had been too energetic to be captured, finally combined with nuclei to form the first neutral atoms. At that moment, light was set free. Photons that had been bouncing from particle to particle could suddenly travel unimpeded across space. That light, the cosmic microwave background radiation, still reaches us today, coming from all directions. The oldest light in the universe. It is a perfect thermal spectrum, almost perfectly uniform, with tiny fluctuations that reveal the seeds of everything that would follow. Those minuscule variations in temperature and density would grow over billions of years into the cosmic web of galaxies, clusters, and superclusters that defines the large-scale structure of our universe today. But here is where certainty begins to unravel into mystery. If the universe is expanding, what is it expanding into? If space itself is stretching, what lies beyond it? The mathematics of general relativity, our most successful theory of gravity and spacetime, offers several possibilities, each more mind-bending than the last. Perhaps the universe is finite but unbounded, like the surface of a hypersphere in 4 dimensions. Just as you can travel endlessly around the Earth's surface without ever finding an edge, you might theoretically travel through the cosmos in a straight line, only to eventually return to your starting point from the opposite direction. In such a universe, there is no outside, no beyond, no edge, just as there is no edge to the Earth's surface despite its finite area. Or perhaps the universe is truly infinite, extending without bound in all directions. In that case, the observable universe, the spherical region from which light has had time to reach us since the beginning, is just an infinitesimal bubble in an infinite ocean. What we call the universe might be just a local neighborhood in a cosmos of limitless extent, containing infinitely many other regions identical to our own observable sphere, along with infinitely many regions with different configurations of matter and energy. Either possibility defies our intuition. If the universe has no edge, then where does it begin? If it has no center, then what point did it expand from? The answer may be that these questions themselves are based on a flawed understanding of cosmic geometry. In the mathematics of expanding, spacetime, every point is potentially the center of its own observable universe. The cosmos did not expand from a point in pre-existing space, but emerged as space itself came into being. Consider the surface of an inflating balloon. If you were a two-dimensional being living on that surface, you would see all other points moving away from you. You might conclude that you are at the center of expansion, but a being at any other point on the balloon would draw the same conclusion. There is no privileged center. Every point expands away from every other point as the balloon inflates. Our three-dimensional universe behaves similarly, though with an additional spatial dimension that strains our capacity to visualize. We're not expanding within space. Space itself is expanding, carrying us along with it. The gaps between galaxies grow larger, not because galaxies are moving through static space, but because space itself stretches between them. This expansion is accelerating. For billions of years after the initial burst of inflation, the expansion of the universe gradually slowed. The mutual gravitational attraction of all matter acting as a cosmic brake. But approximately 5 billion years ago, something changed. The expansion began to speed up, driven by what we now call dark energy, a mysterious force or property of space itself that pushes galaxies apart rather than pulling them together. Dark energy is perhaps the greatest enigma in modern cosmology. It makes up roughly 68% of the total energy content of the universe, yet we have no idea what it is. It could be a cosmological constant, an intrinsic energy density of empty space predicted by Einstein's equations. It might be a dynamic field that varies across space and time. It could be a sign that our understanding of gravity breaks down at the largest cosmic scales. Or it might be something else entirely, something beyond our current conceptual framework. Whatever dark energy is, its effects are profound. If current trends continue, the acceleration of cosmic expansion will eventually isolate every galaxy, then every star system, then every atom from all others. The universe will become colder, darker, more diffuse, stretching toward a state of maximum entropy, a heat death in which no further work is possible, no structure can persist, no life can exist. Yet this grim fate is not certain. Our understanding of dark energy is too limited to predict with confidence what will happen in the far future. The cosmos might continue expanding forever, or it might eventually reverse course, collapsing back into a big crunch that could potentially seed another cycle of expansion. Or it might reach an equilibrium state, neither expanding nor contracting, but maintaining a delicate balance between opposing forces. Now consider the structure of the cosmos at the largest scales we can observe. Galaxies are not distributed randomly, but form a complex web of filaments and clusters with vast voids between them. This cosmic web bears an uncanny resemblance to a neural network, to the structure of the Internet, to the mycelial networks of fungi beneath the forest floor. What are we to make of this similarity? Is it mere coincidence, Or does it reveal something fundamental about how complexity organizes itself across vastly different scales and systems? If the universe has no edge in space, does it have an edge in time? Did time exist before the Big Bang? Will it continue infinitely into the future? Einstein's relativity suggests that time is not absolute, but relative, not a fixed backdrop against which events unfold, but a dimension woven into the fabric of space itself, warped by gravity, experienced differently by observers in different states of motion. What if time as we understand it is merely a local phenomenon, a characteristic of our particular cosmic region or epoch, rather than a universal constant? Some theories suggest that what we call the beginning was not the absolute beginning, but a transition, perhaps from a previous cycle of contraction, perhaps from a higher dimensional reality, perhaps from a state so alien to our understanding that we lack the conceptual framework to describe it. What if what we perceive as a temporal edge, a beginning of time, is actually a boundary of comprehension, a limit not of reality, but of our ability to model it? If the universe has no edge in space or time, does it have an edge in complexity? Is there a limit to how structured, how organized, how conscious the configurations of cosmic matter and energy can become? As the universe evolved from primordial simplicity to its current intricate web of galaxies, stars, planets, living systems, and thinking minds, it has generated forms of astonishing complexity. Is this evolution toward complexity a fundamental tendency of cosmic systems, a counterflow to the general current of entropy, a manifestation of some deeper principle we've yet to fully grasp? These questions lead us to the edge not just of what we know, but of what we can ask with our current conceptual tools. The universe may not only be stranger than we imagine, but stranger than we can imagine, not because our minds are inherently limited, but because they evolved to navigate a tiny corner of reality, to model middle-sized objects moving at moderate speeds in three-dimensional space. When we attempt to comprehend the cosmos at its largest scales or its earliest moments, we strain against the boundaries of conceptual frameworks shaped for a very different purpose. And yet, remarkably, we can stretch those frameworks. Through mathematics, through analogy, through creative synthesis of different modes of understanding, we can reach beyond the limitations of our intuition toward truths that defy direct visualization. We can model realities we cannot picture, describe geometries we cannot directly perceive, develop frameworks for phenomena that transcend everyday experience. Here at the edge of the known universe, where established science meets speculative frontier, we find not a wall, but a horizon, a boundary that moves with us as we advance, revealing new vistas even as it maintains the mystery of what lies beyond our current reach. The cosmos is not a puzzle to be completed, but an endless invitation to deeper understanding, not a territory to be conquered, but a mystery to be continuously engaged. At the edge of our cosmic understanding lies a theoretical object so extreme. It fractures the laws of physics themselves, the singularity. You've heard the term before, perhaps in discussions of black holes or the Big Bang, but what exactly is a singularity? In the language of mathematics, it's a point where equations break down, where values become infinite, where the smooth predictability of physical law shatters against the wall of the inconceivable. In the realm of physics, it represents a boundary beyond which our current understanding cannot penetrate, a cosmic limit to what can be calculated, modeled, or even meaningfully described. Imagine reality as a vast mathematical tapestry, equations, mapping the relationship between space, time, matter, and energy. Now, imagine a hole burned through that tapestry, not merely an absence, but an active contradiction, a place where the fabric of understanding itself unravels. That's a singularity, not merely something we don't yet understand, but something that may be, in principle, incomprehensible within our current frameworks. The most famous singularities in physics occur at the centers of black holes. When a massive star exhausts its nuclear fuel, the outward pressure that maintained its structure against the inward pull of gravity disappears. The star collapses, and if it's massive enough, no known force can halt this collapse. Matter compresses beyond the density of atomic nuclei, beyond the Planck density, theoretically continuing to an infinitesimal point of infinite density, a singularity. At this singularity, space-time curves infinitely. The mathematics of general relativity, our best description of how gravity works, predicts its own breakdown. It's as if the universe itself hits a division by zero error, a fundamental indeterminacy. The singularity isn't just an extremely small, extremely dense object. It's the edge of physical law itself, a boundary beyond which our equations cannot take us. But is this breakdown a feature of reality, or merely a limitation of our theories? Here lies a profound tension in modern physics. Our most successful theories, general relativity describing the very large, quantum mechanics describing the very small, remain stubbornly incompatible. Each works brilliantly in its domain, but fails precisely where singularities arise. This incompatibility suggests that singularities may not be physical realities, but symptoms of our incomplete understanding. Warning signs that we're approaching the borders of our conceptual map. Some theories suggest that quantum effects might prevent true singularities from forming. Perhaps matter can never be compressed beyond a certain density. Or perhaps space itself has a granular structure at the smallest scales that prevents infinite curvature. These approaches don't eliminate the boundary, but push it back, replacing the infinities of classical singularities with extreme but finite values that might, in principle, be comprehensible. Now, let's consider an even more radical theoretical boundary: the cosmic censorship hypothesis. Proposed by physicist Roger Penrose, this conjecture suggests that singularities are always hidden behind event horizons, the boundaries of black holes beyond which nothing, not even light, can escape. Nature, in this view, shields us from direct observation of singularities, hiding these breakdowns in physical law behind veils through which no information can pass. But what if this cosmic censorship could be violated? What if singularities could exist without event horizons to hide them? What physicists call naked singularities? Such objects would expose the breakdown of physical law to the broader universe, potentially allowing cause and effect to unravel, determinism to fail, predictability itself to collapse. The implications would be profound not just for physics, but for our entire conception of a law-governed cosmos. Imagine reality as a film reel, where time is not flowing, but every moment already exists, past, present, and future laid out in a static four-dimensional structure that we experience sequentially only because of our limited perspective. This is the block universe interpretation suggested by relativity, where time is just another dimension, no different in kind from the three dimensions of space. In this view, the flowing experience of time, the sharp distinction between past, present, and future, is not a fundamental feature of reality, but a perspective effect, a consequence of how consciousness interfaces with a static four-dimensional structure. Einstein himself embraced this perspective, writing after the death of his friend Michel Bessot. Now he has departed from this strange world a little ahead of me. That means nothing. People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion. But if time does not flow, if the future already exists in some sense alongside the past and present, what becomes of choice, of possibility, of the open texture of experience. What if every decision you will ever make, every word you will ever speak, every emotion you will ever feel, is already encoded in the static geometry of spacetime? What if free will is not the authorship of an unwritten future, but merely the subjective experience of discovering what always existed? The block universe creates a profound tension between physics and lived experience, between the mathematical elegance of a static four-dimensional reality and the vivid sense of an unfolding. Now that characterizes conscious awareness. This tension has led some physicists and philosophers to seek alternative interpretations, models in which becoming is as fundamental as being, in which the future genuinely does not yet exist, in which possibility remains genuinely open. 1. Such alternative is the growing block universe, in which the past and present are fixed, but the future remains unwritten, with the present moment representing the leading edge of an expanding block of reality. Another is presentism, the view that only the present moment truly exists, with past and future being merely abstractions, memories or anticipations rather than actualities. But these alternatives come with their own difficulties, particularly in reconciling them with the relativity of simultaneity. Einstein's discovery that observers in different states of motion will disagree about which events are simultaneous, about what constitutes now. If there is no universal present moment, how can we maintain that only the present truly exists, or that reality grows only at the moving edge of the present? Now, let's venture even further beyond conventional understanding, to the concept of the multiverse, perhaps the most radical expansion of our cosmic picture. The term multiverse encompasses several distinct theoretical frameworks, each proposing that our universe is just one of many, perhaps infinitely many, realities. The inflationary multiverse suggests that the rapid expansion that occurred in the first fraction of a second after the Big Bang continues eternally in some regions of space, stopping in others to form bubble universes like our own. In this model, our observable universe is just one bubble in an ever-expanding, ever-diversifying cosmic foam, with new universes constantly nucleating from the inflating background. Imagine our cosmos as a vast, effervescent sea, where each bubble represents an entire universe with its own laws, its own constants, its own evolutionary history. Some bubbles might be nearly identical to ours, differing perhaps in the detailed configuration of galaxies or the precise values of certain parameters. Others might be radically different, universes where the force of gravity is stronger or weaker, where atoms cannot form, where time flows in multiple directions, or where spatial dimensions number in the dozens rather than the familiar 3. The quantum multiverse, derived from certain interpretations of quantum mechanics, suggests something even more mind-bending, that reality branches at every quantum event, creating parallel universes that contain all possible outcomes of every interaction. In this model, every decision you make, every roll of the dice, every quantum fluctuation spawns a new universe, with the full collection of universes, the quantum multiverse, containing every possible configuration of matter and energy compatible with the initial conditions and the laws of physics. Imagine reality not as a single timeline, but as an infinitely branching tree. Each branch, a complete universe as real as our own, containing versions of ourselves, making different choices, experiencing different outcomes, living different lives. What would it mean for your sense of identity to know that in some branch of the multiverse you chose a different career, married a different person, or made that crucial left turn instead of right? What would it mean for your understanding of possibility and actuality, of chance and necessity? The brain multiverse, derived from string theory, proposes something different still, that our three-dimensional universe exists on a brane, short for membrane, floating in a higher dimensional space, with other branes, other universes, potentially existing parallel to our own. These universes might occasionally collide, with such collisions possibly explaining phenomena like the Big Bang. Imagine reality as a stack of two-dimensional sheets, like pages in a book, each sheet representing a three-dimensional universe floating in four-dimensional space. What might exist in those extra dimensions? What properties might those other universes have? What would happen if information or energy could somehow leak from one universe to another through rare connections between branes? These multiverse theories aren't merely speculative fantasies. They emerge naturally from some of our most successful physical theories, from inflationary cosmology, from quantum mechanics, from string theory. They represent attempts to follow the mathematics of these theories to their logical conclusions, even when those conclusions radically challenge our intuitive sense of what reality is or might be. Critics argue that multiverse theories are scientifically problematic because they make few, if any, testable predictions. If other universes are causally disconnected from our own, how could we ever detect them or confirm their existence? Does a theory that explains everything by allowing everything really explain anything at all? These are legitimate concerns that multiverse proponents continue to grapple with. But what if we've been asking the wrong questions? What if the very notion of a single objective reality accessible to empirical investigation is itself limited? What if our scientific quest for universal laws, laws that apply everywhere, at all times, without exception, has led us to a boundary beyond which such laws cannot take us? Consider the cosmological principle, the assumption that the universe is homogeneous and isotropic at the largest scales, looking roughly the same in all directions and from all vantage points. This principle has been enormously fruitful, allowing us to develop mathematical models of cosmic evolution that successfully predict phenomena like the cosmic microwave background radiation and the large-scale distribution of galaxies. But what if this homogeneity is merely local? What if, beyond our observable bubble, the universe becomes radically inhomogeneous, with regions governed by different constants, different structures, perhaps even different laws? What if our observable universe is merely a relatively uniform patch in a vastly more diverse cosmic tapestry? This possibility connects to the Anthropic principle, the observation that the physical constants and laws we observe seem finely tuned to allow for the emergence of complexity, of life, of consciousness. If these values were even slightly different, stars could not form, chemistry would not work, water would not exist, intelligence could not evolve. Is this apparent fine-tuning evidence of purpose, of design, or could it be a selection effect? We observe these particular values precisely because they allow for observers like us to exist? The multiverse offers a potential resolution to this dilemma. If there are many universes with varying physical properties, we shouldn't be surprised to find ourselves in one that allows for our existence. The apparent fine-tuning is not evidence of design, but a consequence of the reality that observers can only evolve in universes that permit their evolution. But this perspective, while resolving one mystery, introduces others. What does it mean for a universe to exist if it contains no conscious entities to observe it? What is the relationship between consciousness and reality? Is the act of observation merely the passive reception of pre-existing information? Or does it play a more fundamental role in the actualization of potential into reality? These questions take us to the boundaries not just of physics, but of philosophy, of epistemology, of the meaning of knowledge itself. They remind us that the edge of everything we know isn't merely a limit of our instruments or our theories, but potentially a limit of what can be known, of what knowledge itself means, in a reality that may transcend the very categories through which we attempt to understand it. At the heart of modern cosmology lies a paradox so profound it threatens the coherence of our entire understanding of cosmic history: the horizon problem. The cosmic microwave background radiation, the afterglow of the Big Bang that still permeates the universe, is almost perfectly uniform in temperature, varying by only about 1 part in 100,000 across the entire sky. This uniformity suggests that the early universe reached a state of thermal equilibrium, with energy evenly distributed throughout space. But here's the paradox. Regions of the cosmic microwave background on opposite sides of the sky are separated by distances so vast that, given the age of the universe and the speed of light, they could never have communicated with each other. They're beyond each other's cosmic horizon, the maximum distance from which light could have reached us since the beginning of the universe. How, then, did these causally disconnected regions come to have almost identical temperatures? How? Did they know to equilibrate with each other if no signal could ever have passed between them? This isn't just a minor discrepancy in the data. It's a fundamental challenge to our understanding of how physical systems reach equilibrium. Conventional physics? Thermal equilibrium requires interaction, energy exchange, communication between different regions of a system. If such communication was impossible given the constraints of cosmic expansion and the speed of light, how did the universe achieve its observed uniformity? The most widely accepted solution to this paradox is cosmic inflation, the theory that the early universe underwent a brief but explosive phase of exponential expansion, increasing in size by a factor of at least 10^26 in just a fraction of a second. Before this inflationary period, the regions that now appear causally disconnected were close enough to interact and reach thermal equilibrium. Inflation then dramatically stretched space, separating these equilibrated regions beyond each other's cosmic horizons. But inflation raises its own paradoxes. What triggered this explosive expansion? What caused it to stop? How did the enormous energy of the inflationary field convert into the matter and radiation we observe today? And perhaps, most troublingly, if inflation can happen once, might it happen again? Or might it be happening constantly in different regions of space, leading to the eternal inflation scenario and its implication of a multiverse with infinitely many bubble universes like our own? The horizon problem and its inflationary solution exemplify a pattern we encounter repeatedly at the frontiers of cosmology, an observation that challenges our existing frameworks, a theoretical solution that resolves the immediate paradox, but introduces new questions, often more profound than those it answered. We push back the horizon of ignorance only to discover new mysteries beyond. Consider another profound cosmological paradox: the flatness problem. Observations indicate that the universe is remarkably close to being spatially flat, adhering to the familiar rules of Euclidean geometry, where parallel lines never meet, and the sum of angles in a triangle equals 180 degrees. This flatness requires an extraordinarily precise balance between the universe's expansion rate and its density of matter and energy. If the density had been slightly higher, the universe would have recollapsed long ago in a big crunch. If slightly lower, it would have expanded so rapidly that galaxies could never have formed. The observed flatness requires fine-tuning to at least 1 part in 10^62, an almost inconceivable precision. It's as if the universe were balanced on a cosmic knife edge, with the slightest deviation from perfect flatness growing exponentially over time. Why is the universe so precisely balanced? Is this fine-tuning simply a brute fact? Or does it point to some deeper principle, some mechanism that drove the early universe toward flatness? Again, inflation offers a potential solution. the same explosive expansion that addresses the horizon. Problem would also drive the geometry of space toward perfect flatness, just as inflating a balloon causes its surface to appear increasingly smooth and uniform at smaller scales. But this solution, while mathematically elegant, doesn't resolve the deeper question of why inflation occurred with precisely the characteristics needed to produce the universe we observe. Are we again encountering a selection effect? We observe a flat universe because only flat universes can develop the complex structures necessary for life? Or is there some deeper principle at work, some fundamental reason why the universe must have these specific properties? Now let's explore an even more unsettling paradox: the Boltzmann brain problem. According to the second law of thermodynamics, closed systems inevitably evolve toward states of higher entropy, greater disorder, more uniform distribution of energy. The early universe had remarkably low entropy, and entropy has been increasing ever since, giving us the arrow of time and making complex ordered structures, like stars, planets, and living organisms, possible but temporary. If the universe continues expanding indefinitely, it will eventually approach a state of maximum entropy, a heat death in which energy is distributed so uniformly that no work can be performed, no complexity can persist, no life can exist. In such a universe of near-perfect thermal equilibrium, random quantum fluctuations would occasionally produce temporary decreases in local entropy. The troubling question is this: what's more likely to arise from such fluctuations? An entire, ordered universe like ours, or a single conscious entity with false memories of such a universe? Mathematically, the latter requires a far smaller fluctuation of entropy, and is thus vastly more probable. Following this logic to its conclusion, we're faced with the disturbing possibility that it's more likely for a single disembodied consciousness, a Boltzmann brain, to randomly fluctuate into existence with illusory memories of a universe, than for an actual universe with billions of galaxies to exist. If we accept the principles of thermodynamics and statistical mechanics that have been so successful in explaining other physical phenomena, we're led to the conclusion that each of us is more likely to be a hallucinating Boltzmann brain than a biological organism in a real universe with a 13.8 billion-year history. This paradox isn't merely bizarre, but potentially devastating for our entire scientific enterprise, which assumes the reality of the external world we observe. Various solutions have been proposed, from suggesting that the universe's initial state had exactly the entropy needed to avoid this paradox, again raising questions of fine-tuning or purpose, to questioning whether infinite time is a meaningful concept, to proposing that our universe will eventually undergo a phase transition to a different state rather than continuing to expand indefinitely. But none of these solutions has achieved consensus, and the Boltzmann brain paradox remains a troubling reminder of how our most successful physical theories can lead to conclusions that radically challenge our basic intuitions about reality. Let's turn now to perhaps the most fundamental paradox in modern physics: the measurement problem in quantum mechanics. At the quantum level, physical systems exist not in definite states, but as superpositions of all possible states, described by a wave function that assigns probability amplitudes to each possibility. This wave function evolves deterministically according to the Schrödinger equation, with the superposition of possibilities becoming increasingly complex as the system interacts with its environment. Yet when we observe or measure a quantum system, we always find it in a definite state. One of the possibilities from the superposition with a probability determined by the wave function. The wave function is said to collapse from a superposition of many possibilities to a single actuality. But what causes this collapse? Is it a physical process? And if so, why isn't it described by the Schrödinger equation like all other physical processes? Is consciousness involved in some way, Or is the apparent collapse merely a consequence of entanglement between the system and the measuring apparatus? Different interpretations of quantum mechanics offer different answers to these questions, none entirely satisfactory. The Copenhagen interpretation posits a fundamental distinction between the quantum realm, where superpositions exist, and the classical realm of our everyday experience, where definite states prevail, but it doesn't clearly define the boundary between these realms or explain the mechanism of collapse. The many-worlds interpretation avoids the collapse problem by suggesting that all possibilities in the quantum superposition actually occur, with reality branching into parallel universes, containing each possible outcome. This interpretation preserves the mathematical elegance of the Schrödinger equation, but at the cost of an ontological explosion, infinitely many universes constantly branching from every quantum interaction. The de Broglie-Bohm interpretation maintains that particles always have definite positions guided by a quantum wave function, preserving determinism at the cost of non-locality, instantaneous influences between distant particles that seem to violate the spirit, if not the letter, of special relativity. Each interpretation resolves some aspects of the measurement problem while introducing new conceptual difficulties. After nearly a century of debate, there's still no consensus on which interpretation, if any, correctly describes quantum reality. The measurement problem remains an open wound at the heart of physics, a paradox that has resisted resolution despite the enormous empirical success of quantum mechanics as a predictive framework. What does it mean that our most successful physical theory, confirmed by countless experiments with extraordinary precision, doesn't provide a clear answer to the most basic question of what happens when we observe a quantum system? What does it say about the relationship between mathematics and physical reality, between models and the phenomena they describe, between observers and the systems they observe? These paradoxes, the horizon problem, the flatness problem, the Boltzmann brain problem, the measurement problem, aren't mere puzzles to be solved within existing frameworks. They're boundary markers, signposts at the edge of our understanding, indicators of where our current conceptual tools reach their limits. They don't merely represent gaps in our knowledge, but potential limits to what can be known, at least within the conceptual frameworks we currently employ. This raises a profound question. Are these unsolved problems merely temporary challenges that future theories will resolve, or do they indicate fundamental limits to scientific explanation itself? Are we approaching boundaries beyond which the very concept of scientific law, of deterministic explanation, of mathematical modeling itself breaks down? Consider the limits of reduction, the strategy of explaining complex phenomena in terms of simpler underlying components and mechanisms. Reductionism has been enormously successful in science, explaining chemical properties in terms of atomic structure, biological processes in terms of molecular interactions, cosmic evolution in terms of fundamental forces and particles. But at each level of reduction, new properties emerge that weren't obviously predictable from the lower level. Consciousness from neural activity, life from chemistry, chemistry from quantum physics. What if reality has no fundamental level, no rock bottom of explanation? What if the chain of reduction continues indefinitely, revealing new layers of structure and organization at ever smaller scales? Or what if reduction eventually loops back on itself, creating a circular rather than hierarchical structure of explanation? Either possibility would challenge our assumption that reality can be fully explained from the bottom up, that there is a final theory that captures the fundamental nature of the cosmos. Or consider the limits of mathematical description itself. Mathematics has proven remarkably effective in modeling physical reality, a fact that physicist Eugene Wigner called the unreasonable effectiveness of mathematics in the natural sciences. But why should the universe conform to mathematical description at all? Is mathematics discovered or invented? Does it exist independently of minds that comprehend it? Or is it a human construct, a cognitive tool rather than a feature of reality itself? If mathematics is a human construct, its effectiveness in describing reality becomes almost miraculous. If it's an inherent feature of reality, independent of human cognition, then we seem to have direct access to abstract structures that exist outside space and time, a position that raises its own metaphysical difficulties. Either way, the relationship between mathematical models and physical reality remains profoundly mysterious. Perhaps the deepest paradox of all lies in our very attempt to comprehend the cosmos. We are not detached observers of the universe, but participants within it, products of its evolution, manifestations of its properties and laws. Our cognitive capacities, our conceptual frameworks, our perceptual systems didn't evolve to comprehend quantum fields or cosmic inflation, but to navigate the middle-scale world of predators and prey, of edible and inedible plants, of social alliances and conflicts. That we can comprehend the cosmos at all, that the universe has evolved creatures capable of understanding its own structure and history, is perhaps the greatest mystery of all. Are we approaching the limits of what minds evolved for other purposes can comprehend about a reality that vastly transcends their native scale? Or is there something more profound at work, a deep resonance between mind and world, consciousness and cosmos, that enables the universe to comprehend itself through the medium of human understanding? These questions take us to the very edge of science, to the boundary where empirical investigation meets philosophical reflection, where physical theory encounters epistemological limit. They remind us that the edge of everything we know isn't merely a temporary boundary to be pushed back by better instruments or more powerful theories, but potentially a horizon intrinsic to knowledge itself, to the relationship between knowing, minds, and the reality they seek to know. What does it mean to be human in a universe that has no center, no edge, perhaps no beginning, and no end? What does it mean to be a conscious fragment of cosmos, a thinking reed in an unthinking void, a momentary arrangement of atoms that somehow knows it exists? These aren't merely academic questions. They're existential ones. They strike at the very heart of who and what you are. If time is an illusion, if past, present, and future exist simultaneously in a static four-dimensional structure, then everything you've ever done, everything you're doing now, everything you will ever do, might have already happened infinite times before. Your first kiss, your deepest regret, your final breath, all existing eternally, fixed points in a cosmic geometry that never changes. Your sense of agency, of authoring your own life story, becomes a peculiar kind of illusion. Not because you don't make choices, but because those choices were always already made, eternally encoded in the unchanging architecture of space-time. Feel the weight of that for a moment. The future, your future, already exists. It's already written, already there, waiting for you to experience it moment by moment, like turning the pages of a book whose ending was determined before you opened the cover. The triumph you're working toward, the love you haven't yet found, the death that awaits you, all already present in the frozen river of time. Does this knowledge liberate you or terrify you? Does it render striving meaningless or infuse each moment with the significance of eternity? Or consider the quantum interpretation of reality, where every decision branches the universe, creating parallel worlds where different versions of you made different choices. Right now, as you listen to these words, there might be uncountable other yous experiencing slightly different versions of this same moment. One where you shifted in your seat, one where you paused the video, one where you never watched it at all. These other yous are as real as you are, living lives that diverged from yours through the accumulation of quantum choices, some nearly identical to your experience, others radically different. What if each of those branching realities contains a conscious version of you, experiencing that reality as the only one? What if your consciousness isn't a single stream, but a vast delta, branching into infinite parallel awareness? Where does your identity reside in such a fragmented multiverse? Are you one consciousness or many? If there are infinite versions of you experiencing every possible variation of your life, what becomes of responsibility, of consequence, of the weight of choice? Now, zoom out further, to the cosmic scale. Our most advanced models suggest that everything you can see, all the stars in the night sky, all the galaxies captured by our most powerful telescopes, the entire observable universe stretching 93 billion light-years across, may be just one bubble in an infinite cosmic foam, one region among countless others where space stopped inflating long enough for matter to condense, for stars to form, for life to emerge. Beyond our cosmic horizon, there may be regions so vast that, within them, every possible configuration of matter and energy occurs and reoccurs infinitely many times. This means there may be infinitely many planets identical to Earth, with beings identical to you, reading identical words at this identical moment. Not just similar, identical, down to the last atom, the last thought, the last quantum state. And not just one such planet, but infinitely many, scattered across an infinite cosmos. What does that do to your sense of uniqueness, to the meaning you attribute to your existence? If you are replicated infinitely, are you still you? Does the uniqueness of your consciousness persist, even if the pattern it embodies is repeated elsewhere? What if the universe is alive, and we are just its fleeting thoughts? What if consciousness isn't limited to biological systems but is a fundamental property of reality itself, expressing itself through us but not contained by us? What if the cosmos isn't merely the stage upon which the drama of consciousness unfolds, but is itself a vast, integrated awareness of which our minds are tiny, temporary fragments? These aren't merely poetic metaphors. Some of our most accomplished physicists have proposed that consciousness may be intrinsic to the fabric of reality, that the universe may be fundamentally mental rather than material. If information, not matter or energy, is the basic substrate of reality, and if consciousness is essentially an information processing phenomenon, then consciousness and cosmos may be more intimately connected than our conventional frameworks suggest. Now let the full weight of cosmic scale wash over you. You exist on a rocky planet orbiting an average star in a galaxy of 100 billion stars, which is itself one of hundreds of billions of galaxies in the observable universe. Your entire lifespan is less than an eye blink in cosmic time. The atoms that make up your body were forged in the hearts of dying stars billions of years ago. The light reaching your eyes from distant galaxies left its source when your species didn't yet exist and will continue traveling long after our sun has exhausted its fuel and expanded to consume the inner planets of our solar system. The universe is not built on a human scale. It's not designed for our comprehension. Its vastness and complexity so far exceed our cognitive capacities that even our most sophisticated mathematical models are mere approximations, elegant simplifications of a reality too intricate for direct apprehension. Our brains evolved to track predators and prey, to navigate social hierarchies, to find food and shelter and mates, not to comprehend quantum fields or 11-dimensional brains or the curvature of spacetime. And yet, paradoxically, those same Brains have deduced the existence of phenomena far beyond their direct perception. Through mathematics, through imagination, through the collective enterprise of science, we've glimpsed aspects of reality that transcend our sensory experience by orders of magnitude. We've detected particles smaller than atoms and mapped structures larger than galaxies. We've traced cosmic history back to fractions of a second after the Big Bang and projected it forward billions of years. This capacity to transcend our perceptual limitations through abstract thought, to model realities we cannot directly experience, may be the most remarkable feature of human consciousness. We are finite beings capable of reaching toward infinity, temporal creatures able to conceive eternity, limited minds that somehow grasp their own limitations. In that reaching, in that conception, in that grasp, we participate in something that exceeds us, that contains but is not contained by our individual awareness. Now face the cosmic horror. What if, despite all our intellectual achievements, all our scientific progress, we're fundamentally incapable of comprehending the true nature of reality? What if the universe isn't just stranger than we imagine, but stranger than we can imagine? What if our cognitive limitations aren't merely practical but absolute? Not just a matter of insufficient information or inadequate theories, but of intrinsic constraints on what any mind evolved within this universe can possibly understand about the universe itself. Consider the possibility that we're like characters in a two-dimensional world trying to comprehend three-dimensional reality, or like ants attempting to understand quantum mechanics. Perhaps beyond the horizon of our understanding lies a domain so alien to our conceptual frameworks, so radically different from anything our minds evolved to process, that we can never access it directly, never model it accurately, never truly know it. This isn't merely a speculative possibility. It's a direct implication of the fact that our brains evolved under specific selective pressures for specific adaptive purposes, none of which involved understanding quantum gravity or cosmic inflation or the true nature of consciousness. Our cognitive architecture, our perceptual systems, our conceptual frameworks, all were shaped by the demands of survival and reproduction in specific ecological contexts, not by the demands of universal comprehension. If this is true, if there are aspects of reality that fundamentally exceed our cognitive grasp, then the edge of everything we know isn't merely a temporary boundary to be pushed back by better instruments or more powerful theories. It's an absolute limit, a horizon beyond which lie truths forever inaccessible to beings constituted as we are. And yet, even this sobering recognition contains a kind of wonder, a kind of meaning. The fact that we can conceive the possibility of our own cognitive limitations, that we can model the constraints on our models, that we can imagine realities beyond our imagination. This reflexive capacity, this ability to transcend ourselves through thought, even as we remain bound to ourselves in being, is itself remarkable, itself worthy of awe. Perhaps what makes us human isn't our ability to comprehend the cosmos, but our ability to stand in wonder before it, to recognize its mystery without trying to eliminate it, to participate in a reality we can never fully grasp. Perhaps meaning isn't found in the answers we discover, but in the questions we ask. Not in certainty, but in the humble recognition of uncertainty. Not in mastery, but in the vulnerable openness to what transcends us. Look up at the night sky. Feel the cold vastness pressing down on you. Recognize that you are made of the same elements as those distant stars, governed by the same physical laws, emerging from the same cosmic processes. In that recognition, in that connection between your finite awareness and the infinite depths of space and time, something profound happens. the universe becomes aware of itself through you. The cosmos contemplates its own mystery through the medium of your consciousness. In this vertiginous moment, balanced between knowledge and ignorance, between the vastness of cosmic reality and the limitations of human understanding, we find ourselves at the edge not just of what we know, but of what we are. And in that precarious position, that existential borderland, we encounter not just scientific questions, but human ones, questions of meaning, of value, of how to live with dignity and purpose in a universe whose depths we can glimpse, but never fully sound. Throughout our journey to the edge of everything we know, we've examined paradoxes and possibilities, horizons and boundaries, the puzzling periphery where certainty dissolves into mystery. But what if the greatest revelation isn't waiting at the outer limits of our knowledge, but has been hiding in plain sight all along? What if the answer to the deepest cosmic questions isn't beyond our grasp, but staring back at us from every direction, from every point in space and time? Consider this possibility. What if the universe is a hologram? Not in the metaphorical sense, but in the precise mathematical sense developed by theoretical physicists. The holographic principle suggests that all the information contained in a volume of space can be encoded on its boundary, its surface area rather than its volume. Just as a two-dimensional holographic film can encode all the information needed. To recreate a three-dimensional image, the information defining our three-dimensional reality might be encoded on a distant two-dimensional surface at the boundary of our cosmic horizon. This isn't mere speculation. It emerges from our attempts to reconcile quantum mechanics with gravity, particularly in the context of black holes. When matter falls into a black hole, its information seems to vanish from our universe, violating the quantum principle that information can never be destroyed. The resolution, proposed by physicists like Leonard Susskind and Gerard T. Hooft, is that the information isn't lost, but encoded on the black hole's event horizon, its two-dimensional boundary. Extend this principle to the cosmos as a whole, and you arrive at the holographic universe. Imagine the visual, the entire cosmic panorama, galaxies spinning in the void, stars exploding in silent brilliance, planets orbiting in stately procession, all of it a projection from information encoded on a surface so distant it lies beyond our observable reality. The three-dimensional space you inhabit, the very volume your body occupies, might be an emergent phenomenon, a holographic rendering of data stored in two dimensions. If true, this would represent a complete inversion of our understanding of reality. The solid, volumetric world you experience, with its depth, its extension in three dimensions, its apparent substantiality, would be a kind of cosmic illusion, not in the sense of being unreal, but in the sense of being derived, emergent, projected. The fundamental reality would be the encoding on the boundary, not the volumetric experience within it. Now, let this twist your perception further. What if the universe is already dead, and we are just experiencing its last echoes? What if what we perceive as the dynamic unfolding of cosmic history is actually the time-reversed reading of information encoded at the final singularity, the ultimate fate of a collapsing universe? Some theoretical frameworks suggest that time's arrow might point in opposite directions on either side of the Big Bang. The expansion we observe might be mirrored by a contraction in a time-reversed twin universe. Our perception of entropy increasing, of systems becoming more disordered over time, might be reversed in this mirror reality, where entropy decreases and order spontaneously emerges from chaos. Picture entire galaxies rushing back together, stars unexploding in reverse, clouds of gas compressing into brilliant points of light. Imagine the final moments of universal collapse, where all matter and energy converge toward a single point of infinite density. A singularity not unlike the one from which our universe supposedly emerged. What if that final singularity and the initial singularity are one and the same? What if the end of the universe is also its beginning? In this model, what we experience as cosmic history unfolding forward in time might actually be information radiating backward from the final state of the universe. Our sense of causality, of before and after, of cause and effect, might be a perspective effect rather than a fundamental feature of reality. We might be living, in essence, in the afterglow of cosmic death, experiencing as progressive creation what is actually the time-reversed radiation of ultimate dissolution. Contemplate the visual, the entire cosmos as a vast standing wave, oscillating between expansion and contraction, between dispersion and convergence. Galaxies spinning through the void like luminous snowflakes in a cosmic blizzard. Their apparent motion toward greater separation actually the time-reversed image of their eventual reunion. The cosmic microwave background, that faint glow from all directions that we interpret as the aftermath of the Big Bang, might be equally interpreted as the foreshadow of the Big Crunch, the ultimate compression at the end of time. But let's push beyond even this perspective-shifting possibility to something even more radical. What if there is no universe at all? This isn't nihilism, but the logical extension of certain quantum interpretations. In quantum mechanics, systems exist as superpositions of all possible states until observed or measured, at which point the wave function collapses to a single definite state. But what constitutes an observation? What counts as a measurement? Some interpretations suggest that consciousness itself, the aware observer, plays a crucial role in this collapse, in the actualization of potential into concrete reality. If consciousness is indeed fundamental to the manifestation of definite reality from quantum potentiality, then perhaps the universe, as we know it, with its galaxies and stars, its planets and living beings, exists as actualized reality only insofar as it is observed, only insofar as conscious entities within it perceive and measure it. The observed universe may be the product of the observer, rather than the observer being the product of the universe. Visualize this mind-bending possibility. Cosmic vistas of unimaginable scale and beauty. Spiral galaxies rotating in the darkness. Stars exploding in silent fury. Planets forming from disks of dust and gas. All of it existing as definite reality, only where and when conscious observers actualize it through the act of observation. The rest remains in a state of quantum superposition, a cloud of possibility rather than determined actuality. What if consciousness isn't just an emergent property of particularly complex physical systems, but a fundamental aspect of reality itself? The means by which quantum possibility becomes classical actuality. What if the cosmos isn't just observed by consciousness, but manifested through it? This would invert our entire understanding of the relationship between mind and world. Rather than consciousness being a late-emerging property in an already existing physical universe, the physical universe might be continually emerging through the action of consciousness itself. Reality might be less like a pre-existing stage upon which conscious beings eventually evolved, and more like a participatory dance between observation and potentiality, between mind and quantum possibility. Envision swirling galaxies crystallizing. From quantum fog, as conscious observation focuses on them, their spiral arms becoming definite, their billions of stars resolving from probability clouds into actual, radiating suns. Imagine the universe as a vast quantum computer, its calculations resolving into definite outcomes only where consciousness engages with them, the rest remaining in computational superposition in a state of multiple simultaneous possibilities. Perhaps the edge of everything we know isn't out there in the furthest reaches of space or the earliest moments of time, but right here, in the mysterious interface between consciousness and world, in the enigmatic boundary between the observer and the observed. Perhaps reality itself is continually created at this boundary, continually manifested through the interaction between mind and quantum potentiality. If so, then your consciousness isn't merely a witness to cosmic evolution, but a participant in it, not merely a product of physical processes, but a co-creator of the reality those processes constitute. You are not just in the universe. The universe is, in some profound sense, in you, actualized through your observation, manifested through your awareness, created anew in each moment of conscious perception. This isn't solipsism. The universe doesn't exist only in your individual mind, but it suggests that mind itself, consciousness in all its forms, including but not limited to human awareness, plays a fundamental role in the manifestation of concrete reality from quantum possibility. Reality may be neither purely subjective nor purely objective, but intersubjective, created through the participation of multiple conscious agents in a shared quantum field of possibility. As the camera pulls back to reveal the full cosmic vista, galaxies upon galaxies receding toward a horizon that curves back upon itself, forming a vast sphere of luminous points. Consider this final haunting thought. If the universe is indeed infinite, containing all possible configurations of matter and energy, then somewhere out there exists another planet exactly like Earth, with another person exactly like you, watching this exact video at this exact moment. Not just one such planet, but infinitely many, scattered across the boundless expanse of cosmic reality. And if quantum many-worlds theory is correct, if every possible outcome of every quantum interaction manifests in some branch of an endlessly bifurcating multiverse, then there are also infinitely many versions of you who chose not to watch this video, who are living slightly different lives based on slightly different choices, who are experiencing realities that diverged from yours through the accumulated butterfly effects of quantum chance. Between the infinities of cosmic space and the infinities of quantum possibility, you, yes, you, exist not as a singular entity, but as a multiplicity, a chorus of selves singing slightly different songs across the quantum branches of an infinite cosmos. The edge of everything we know isn't a boundary that separates you from the mystery. It's a horizon that connects you to it, that reveals your intrinsic participation in the greatest enigma of all, the enigma of existence itself. We've journeyed together to the edge of everything we know, from the silent non-bang of cosmic birth to the holographic possibility that our three-dimensional reality emerges from information encoded on a distant two-dimensional surface. We've contemplated time as an illusion, space as a projection, consciousness as a co-creator of the reality it perceives. We've stood at the boundary between knowledge and mystery, between the mapped territory of scientific understanding and the vast unknown that stretches beyond our current horizons. But this journey doesn't end here. It can't end here. For the edge of knowledge isn't a destination, but a frontier. Not a wall, but a doorway. Not a conclusion, but an invitation. Each answer we've found has birthed new questions. Each mystery solved has revealed deeper enigmas. Each horizon crossed has unveiled vaster horizons beyond. This is the paradoxical gift of the scientific quest. The more we learn, the more we discover how much remains unknown. What we call reality has proven stranger, more complex, more fundamentally mysterious than our ancestors could have imagined. The solid ground of common sense has dissolved beneath our feet, revealing quantum uncertainties, relativistic paradoxes, multiversal possibilities. The clear boundaries between observer and observed, between past and future, between actuality and possibility, have blurred into continua of mutual influence, endless recursion, cascading probabilities. And yet, amidst this vertiginous complexity, patterns emerge. Mathematical regularities govern phenomena across vast scales. Physical constants maintain their precise values across billions of light years. The laws of thermodynamics, of quantum mechanics, of general relativity, however mysterious their deeper foundations, yield predictions that match observation with astonishing precision. The universe may exceed our full comprehension, but it reveals itself as comprehensible in part, as accessible to reason, as responsive to our persistent questioning. Perhaps this is the most profound mystery of all, that the universe has evolved. Creatures capable of comprehending it, however partially. That matter has organized itself into minds that can contemplate their own origins. That the cosmos has developed the capacity to reflect upon itself through the medium of conscious experience. You are not separate from the mystery you contemplate. You are an expression of it, a manifestation of the universe's intrinsic tendency towards self-awareness. Consider how far we've come in our cosmic understanding. A mere century ago, we thought the Milky Way constituted the entire universe. Today, we know it as one galaxy among hundreds of billions in the observable cosmos alone. A mere century ago, we thought space and time were absolute, independent backgrounds against which events unfolded. Today, we understand them as aspects of a single dynamic space-time continuum, warped by mass and energy. A mere century ago, we thought matter consisted of solid particles with definite properties and positions. Today, we understand it as manifestations of quantum fields existing in superpositions of multiple states until measured. What transformations in understanding await us in the century to come? What paradigm shifts will make our current models seem as limited as the pre-Copernican cosmos seems to us today? What conceptual revolutions will push back the edge of everything we know, revealing new territories of comprehension even as they illuminate new mysteries beyond? The journey of discovery doesn't belong to scientists alone. It belongs to all of us who wonder, who question, who refuse to take reality at face value. Every time you look up at the night sky and feel that surge of awe at the vastness above you, every time you contemplate the strange miracle of your own consciousness, every time you ask why, or how, or what if, you're participating in humanity's greatest adventure, our collective exploration of the mystery we inhabit. This exploration takes place not just in particle accelerators and astronomical observatories, but in philosophy seminars and art studios, in moments of solitary reflection and vibrant conversation, in the quiet wonder of a child gazing at the stars, and the rigorous mathematics of a theoretical physicist. It happens whenever we refuse to settle for easy answers, whenever we push against the boundaries of the known, whenever we hold space for mystery without abandoning the quest for understanding. What if this quest, this reaching beyond what we know toward what we don't, is itself a fundamental feature of the cosmos? What if the universe evolves not just in the sense of physical systems becoming more complex over time, but in the sense of becoming more aware of itself, more capable of self-reflection, more fully actualized as a knowing entity through the medium of conscious beings like ourselves? What if our questioning is the universe's way of questioning itself? Our discovery is the universe's way of discovering itself. Our wonder is the universe's way of wondering at its own mysterious existence. This perspective doesn't reduce science to mysticism. It grounds mystical intuition in scientific discovery. It doesn't abandon reason for revelation. It recognizes reason itself as a kind of ongoing revelation, a gradual unveiling of patterns and principles that were always there to be discovered. It doesn't retreat from the edge of knowledge, but advances toward it with both rigorous skepticism and profound openness, with both mathematical precision and poetic sensibility. As our scientific understanding has expanded, it hasn't eliminated mystery, but transformed it. The mysteries we face today are not the same as those that puzzled our ancestors. They're deeper, more fundamental, more closely tied to the basic nature of reality itself. We've moved from wondering what the stars are made of to wondering about the quantum fields that give rise to matter itself. From questioning where Earth sits in the cosmos to questioning what the cosmos itself emerges from. From asking how living things differ from non-living things to asking what consciousness itself might be. Each of these transformations represents not just an expansion of knowledge, but a deepening of mystery. Each represents not just an answer, but a more profound question. Each takes us closer to the edge of everything we know and reveals new horizons beyond that edge. And here we arrive at one last chilling question, perhaps the most profound of all. What if the edge of everything we know isn't just a limit of our current understanding, but a boundary intrinsic to understanding itself? What if there are aspects of reality that cannot, in principle, be captured by any conceptual framework, any mathematical model, any theoretical structure accessible to minds like ours? What if the cosmos isn't just stranger than we imagine, but stranger in ways that transcend our capacity to imagine? This possibility doesn't diminish the scientific enterprise, it elevates it. It suggests that our quest for knowledge is not a finite task to be completed, but an infinite journey to be embraced. Not a puzzle to be solved once and for all, but a mystery to be engaged endlessly, with ever-deepening insight, ever-expanding wonder. It suggests that the edge of everything we know isn't a terminus, but a threshold. Not an ending, but a beginning. What lies beyond that threshold? What awaits us at the horizon of human understanding? What mysteries remain to be discovered? What paradigms remain to be shifted? What revolutions in thought remain to be achieved? These aren't rhetorical questions, they're invitations. Invitations to wonder, to question, to imagine, to participate in the greatest intellectual adventure our species has ever undertaken. Perhaps you're watching this video as a student, considering a career in science or philosophy. Perhaps you're a veteran researcher, already working at the frontiers of human knowledge. Perhaps you're simply a curious mind, drawn to the big questions that have captivated humanity since we first gazed up at the stars with wondering eyes. Wherever you are in your own journey of discovery, know that you're part of something larger than yourself, a collective human endeavor to comprehend the incomprehensible, to articulate the ineffable, to map the unmappable terrain of existence itself. This endeavor needs you, your questions, your insights, your unique perspective. The edge of everything we know doesn't advance through the work of isolated geniuses alone, but through the collective intelligence of a global community of inquiry, through the contributions of countless minds approaching the mystery from countless angles. The next paradigm shift, the next conceptual revolution, the next transformative insight might come from anyone, perhaps even from you. So keep questioning. Keep wondering. Keep probing the boundaries of what you know and don't know. Watch the sky. Read widely. Talk with others who share your curiosity. Follow your questions wherever they lead, even when, especially when, they take you to uncomfortable places, to conceptual terrain where solid ground gives way beneath your feet, where certainties dissolve into possibilities, where the familiar becomes strange. and the strange becomes familiar. Remember that every great scientific advance began with a question that wouldn't go away, with a curiosity that couldn't be satisfied, with a puzzle piece that wouldn't fit into the existing picture. Remember that the cosmos reveals itself not all at once, but layer by layer, horizon by horizon, to those patient and persistent enough to keep looking, to keep asking, to keep wondering. As you continue your own journey to the edge of everything, remember that you carry within you the same fundamental mystery you seek to understand. Your consciousness, your capacity for wonder, your ability to formulate questions about the nature of reality. These aren't incidental features of an otherwise unconscious cosmos, but expressions of the universe's intrinsic potential for self-awareness. You are the edge where the universe becomes conscious of itself, where matter awakens to its own meaning, where the mystery recognizes itself as mystery. And so we end where we began, with wonder, with question, with the recognition that the edge of everything we know isn't a boundary that separates us from the mystery, but a horizon that connects us to it. We end not with closure, but with opening, not with answers, but with deeper questions, not with certainty, but with the humble, exhilarating recognition of how much remains unknown. The universe may have no edge, but our understanding always will. And in that space between what we know and what we don't, that fertile borderland, that creative frontier, lies the future of human knowledge. The next chapter in our cosmic story, the next stage in our collective awakening to the wonder of existence. The universe may have no end, but neither does our journey to understand it. Neither does our capacity for wonder. Neither does our quest for meaning amidst the vast, incomprehensible beauty of all that is. Neither, perhaps, do you.